if you forget to put your name, it won't matter. As soon as you've got whatever it is you're here for, feel free to leave and get started on your revision. First thing I'm going to talk about is just double checking. It's Friday, 1 till 4, right? Turn up 10 minutes early if you want. Let's show you what I have already online. Kick in, here we go. If you click on information about the final exam, let's check. Are you looking at Canvas? Am I on the right page? Right. So if you click on this one here, it tells you written a version of all the good stuff. For instance, here are the topics. If you then go down final exam Zoom link, that's the Zoom link that you'll use on Friday. This is our last day. I won't see you until Friday after that. This one here is where you'll get the multiple choices. So when you click on this, just get a placeholder right now, but there'll be a PDF there with your 20 questions. And remember what I said last time, I don't want to see working for any of this. I just want to see 1 is A, 2 is B. What do you do, Eric, if you don't know the answer to question 3?
Skip it and come back to it if you have time.
Oh, that's a better answer. I was hoping you just say pick C and move on, right? Just guess. But your answer's better. Brendan, if you're going to take 10 minutes to do a multiple choice, should you?
No.
You're doing it the wrong way, right?
Yes.
So pick A, B, C, or D, and then move on. Right. The multiple choice should be quick. That's what they're there for. Now, when you finish the multiple choice, and this is the order I would do it, multiple choice are quick and easy, and probably you're going to get quite a few points and feel good, moving on. You then nip over to WebAssign, and it will appear in WebAssign, and basically it will be, final exam section 2, and that's where the other 10 questions are going to live, right? And in the section 2 questions, there are going to be some questions where you'll use SALT and other questions where you have to do lots of working. Try and show me every piece of working in section 2 that you can. In fact, if you go into SALT, will you write down the numbers that you were using inside SALT, so that if you make a mistake, I can tell what you were doing, and that would help. That'll help me give you points. And for the life of me, I don't know where it is, but there we are. Oh. And if you look down here, practice tests and final exam. So if you click on this guy, eventually, it's loading up. And these will just give you questions. Quite good for the multiple choice, because basically the multiple choice, when this ever decides to load up, will be questions, like A, B, C, D, and it'll be the usual kind of thing. It's still loading, big circle. How do you know a Scottish house at Christmas time? Parking meter on the roof. Barbara, parking meter on the roof.
And charge Santa to park, huh?
They charge Santa to park us. God, heckin' sassafras. If I have to describe it, Barbara, it wasn't that good a joke, right? Oh, now she's smiling. Okay. Right. Can you trust me that eventually that thing will load up? And it has, basically, it'll give you a chance to practice. So when you come in on the day of the final, only this one here, the one that says final exam, will be here, right? All the other stuff will disappear. All the homework that you've done in WebAssign will also disappear. So I suggest really strongly that you make sure that you get really good notes and you prepare as well as you can. And
it'll be open on Thursday, right?
Say again, Isabel?
It'll be open until Thursday, right?
Yeah, it'll disappear when, probably Thursday night. That's when I'll probably do it, maybe Thursday morning, whatever. But it'll disappear before the test. Where's it going? Yeah, when you're writing your notes, especially the formulas, it might be, I suggest, just me, that you might want to write down not just the formula, but where you would use it. So give you a kind of example of what that might look like. You might write something like this. Formula to use when you are calculating z-score. What's the difference in two proportions? And the z-score is p1 hat take away p2 hat over the standard error of p1 hat over p2. So I don't just write the formula down. I try and write a little, say, this is when you use that formula. Now, you don't need to use my words. It's much better if you use your own words, right? So when you go through your formula, you're not just going to be looking for a formula, you're going to be looking for the formula that does this or does that. Oh, by the way, I haven't finished this question. Don't you have to know that guy? Tried it with the other class. Nobody remembered it. Anybody want to go for it in this class?
Is it P1 times 1 minus P1 over N, or is it
Anything else? That
N1
so far, right? And
plus P hat 2 times 1 minus P hat 2 all over N2.
yes. Well, the fact that you did that off the top here, but it's going to be helpful because if you know the formula, can't you just write it down and start using it? And it saves you spending 3 or 4 minutes trying to find it in the 20 other bits of paper you've got in front of you, and then double checking that it's the right formula because you don't want to just do the first one that vaguely looks like it could work. Right, so that is essentially an example of how you would do it. Okay, so now it's open season. Ask me anything you like, and I'll try and answer it as best I can. Who's got the first question?
I have specific questions on some of the homework, like on the
Sure.
chapter 7, the intro to probability A.
Okay,
That section.
hold that thought while I load it up. Okay, still loading up. A few more buttons to press. So, any specific version of the question within that?
There, so the end of that test, like questions 11 through 14, I couldn't remember how to get those probabilities.
Okay, let me find, actually, let me find yours. That way the numbers will be the same ones you're seeing. Okay, so here we do, R, gotcha, into scores. It was intro to probability A or B?
A.
A.
I'm starting on number 11.
Okay, let's do responses. Well, it looks like you got them all right, but you can't remember
I don't remember
what
how
you
I
did.
did it.
Okay, gotcha. Starting at number 11, did you say?
Yes.
Okay. Yeah, well, there's no point in me showing you. Let's just write it down. Suppose that people are equally likely to be born on any of the 7 days. Well, that makes sense, right? Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, right? There's 7 days. The probability then that you're going to be born on a Friday, isn't that just 1 out of 7?
Yeah.
Right. Now, what's the probability that you have 2 friends So basically, what's the probability that you get a Friday in your first friend and your other friend's also a Friday? Well, if you make the assumption that your two friends, the day of the week they were born on, are independent, right? As long as they're not twins, that's the only time I can imagine it. What that allows us to do is use what's called the multiplicative property of probabilities. And you basically just multiply the two together and you get 1/49th. So far, so good?
Yes.
Now, if I'd asked a different version, they didn't ask in this, but let me put it in. What's the probability that they're not both on a Friday? Then wouldn't that be one takeaway, the guy? And that would be a very large probability, right? Can you remember a guy called the complementary probability? It's one minus the other guy, right? So they might have asked you that. I know they didn't, but they might have. What they did ask you is, for the final one, that was A, and this was B. And for the final question, they asked you the probability that they were both born on the same day. And what you have to figure out here is that that is actually both of them on Monday, or both of them on Tuesday, or both of them on Wednesday, or both of them were Thursday, or both of them were Friday, or both of them were Saturday, and finally, or both of them were Sunday. And when you see the word or, you should think of that as being added. Now, when the events are disjoint, right, they don't share anything in common. Would you agree if you were both born on Monday, then you can't both be born on Tuesday, right? There's no overlap in those situations. And so what you've basically got is 1/7 plus 1/7, 1/49th, I'm using the wrong number. 1/49th, you're both on Tuesday. 1/49th, 1/49th, blah, 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 blah. Aren't there 7 of these? One for Monday all the way to Sunday. And so when you add them together, you get 7/49. And guess what? You end up back at 1/7.
That makes sense.
Now, let me do a more difficult version of that question, because we're on probabilities. Suppose I tell you that the probability that it snows tomorrow is 0.05, right? So there are 5% chance that it snows. And I tell you that the probability that it snows are independent of each day. So if it snows today, tomorrow it might or might not snow, and it's still the same probability, right? Now, when you know something, you also know, I can't think of a better way of phrasing it, so I'll just call it not snowing, right? Won't the not snowing be the other 95%? Does that make sense? If it snows 5% of the time, then the chance that it doesn't snow tomorrow, that's maybe a better phrase, doesn't snow, is 0.95. We can match these with combinations like this. For instance, the probability that it snows for 3 days in a row will be the probability that it snows times the probability it snows times the probability it snows. And because they're independent of each other, we can get away with just multiplying each one together. And I don't know what that is, but I can tell you on the calculator, isn't it the same thing as that guy?
How do
So-
you know if you're multiplying versus adding?
Okay, get this guy down. Wrong, 0.05. I will answer that shortly. Oh, that's a horrible number, but it's basically that guy there. Right, tiny chance. Right. If you are talking about 2 events, one after the other, like Monday and then Tuesday, like the probability that it snows on the Monday and it then snows on the Tuesday. So when you see this word and, even if it's not specifically mentioned, isn't snow and snow got the word and in the middle, even if you don't write it? So when you see that, think of multiplying. Now, a different story, because they can't really do it with this one. If you see the word or, right, both on Monday, or both were Tuesday, or both was Wednesday, you see the or transfers into pluses. Right, so that's how I would do it. I can't really think of a story here where I would do an or, because this particular story doesn't lend itself to that question. But
You
some
do
it
like
does.
it over the course of 4 days, you know, or 3 days.
Well,
Yeah.
those questions get kind of
One day,
messy.
it didn't snow another
Yeah. Here's a version of that, but it shows you that you don't do adding. What's the chances, for instance, that it snows at least once in 3 days? So this is one of those at least. You remember those probabilities where the word at least kicks in? These are the weird ones. What you're going to do here is not find that guy at all. What you're going to find instead is its complement. And so one take away the complement will get you this. What is the exact opposite of snows at least once in 3 days? What's the opposite of that?
No snow in the next 3 days.
Right? So no snow for 3 days in a row. And that's basically no snow, no snow, no snow. And that is still multiplication. Don't know why that P looks weird. There we go. And no snow was what, 95? To save a whole lot of time, can I just put 95 cubed? And so 1 take away 0.95 cubed, and the answer I get is 0.143, roughly, 3 decimal places. So there may be a 5% chance that it snows on any given day. But if you're looking at a 3-day period, the chances that it snows at least once out of those 3 days is going to be 0.143. We got another question. Oh, to answer your earlier question, if you see the word or, it's typically going to be things added. And if you see the word and, it's typically going to be things multiplied. In these types of stories, right, where there's something happens on the first day and something happens on the second day and then something happens on the third day, that kind of story. Right, where are we off to now?
I don't want to steal the floor, but if nobody's going to jump in there,
Right, yes.
I have questions on, this is chapter 7. It's the intro to probability B though.
Okay, I'll just move out of this one and into the B's.
And it's number 11 on that one as well.
Oh, so I'm about question 11. It's probably just a coincidence. So let's see what that one's like. So it says, suppose the A and B are mutually exclusive. Right, so we're told that A and B are mutually exclusive. Now that term means that they share nothing in common, right? So if A is to do with cards, and B is obviously to do with cards as well, there aren't any cards that are in A and in B. So mutually exclusive would be clubs and diamonds, right? Not mutually exclusive would be clubs and kings. Would you agree that there's an overlap in that setting situation? So if you are mutually exclusive, then the probability of A or B is simply just adding them together. Now, before we even get into their question, if A and B are not mutually exclusive, then the probability of getting A or B gets a little bit more complicated. It's the probability of A plus the probability of B, take away the probability of A and B, in other words, both. So for instance, if we do a card question, let's do 2 card questions and then we'll go into yours. Suppose A was getting clubs and B was getting diamonds. Would you agree that these are mutually exclusive events? So the probability that you get A or B, so you pick one card and it's a club or it's a diamond, is the probability of A, which is a club, added to the probability of B, which is a diamond. And we know that there's a 1 in 4 chance that you get a club and a 1 in 4 chance you get a diamond. So you add them together and the answer is a half. So when 2 events are mutually exclusive, you can find the or by adding them. Suppose we do A as clubs, but we do B as kings. Would you agree these are not mutually exclusive? Aren't there some clubs that are kings? So when you're asked to find A or B, which is the probability that you pick just one card and it's a club or a king, it's a probability of a club added to the probability that it's a king, take away the probability, I'm just going to call it both. Now there's a 1 in 4 chance that there's a club, there's a 1 in 4 chance that it's a king. What is the probability that you got a club that's also a king? So how many of the 52 cards are clubs that are kings? Maybe getting an answer in the chat, but I can't hear any answers.
I'm sorry, but the probability of kin is not 1/4, right?
Charles, I'm not sure what your question is. I was
The-
asking, what's the?
The second 1/4
Uh-huh.
is not.
Oh God, that's not. Oh, thank you. Whoa. Yes, you are right. It's 1 out of 13. Quite right. What's the probability that you get a club that's a king or a king of clubs?
Just 1.
Out of?
52.
Right. And that is clubs. That is kings. Take away both. I think I've phrased it, I use the phrase a lot, double dipping. Because you see, you don't want to count the same thing twice. Right. So if it's written down in that way, it's simply just going to be 1/4, add 1/13, take away 1/52, and then hit math button and choice number 1, and you get 4/13. So the chances that you get a club or a king is 4 out of 13. Here's another way of doing the same thing. So the probability of getting, instead of A's and B's, I'll write down who they are. Clubs or a king. You could write it as all over 52. 13 clubs, 4 kings, take away 1 that's a king and a club. And that gets you 16 out of 52, which simplifies to 4/13. So you see the 2 different ways of approaching that question. Same answer, just 2 different ways of looking at it. So after doing that big intro, we haven't answered your question. So let's go to your question now. So suppose then that the probability of getting A is 1/4 and the probability of getting B is 1/2. And you're told that A and B are mutually exclusive. So that's information that you're giving me. Are A and B independent? There is a test for independence. Shouldn't the probability of A given B be equal to the probability of A? And if that is true, then A and B are considered to be independent events. Okay. Now, what's the probability of A given B? Since these are mutually exclusive, if I tell you event B has happened, doesn't that guarantee that event A can't happen? So the answer is 0. Imagine A was black cards and B was red cards, just for argument's sake, right? What's the probability that you get a red card given that it was a black card? Would you agree that those are 0 events? And if 2 events are mutually exclusive, then the conditional probability of one given the other is always 0. On the other hand, isn't the probability of A happens to be a quarter? When you compare these two, do you see that they are not equal? So the conclusion is, if they are equal, the 2 events are independent. If they are not equal, as they are here, what is the conclusion?
They're dependent.
Right, we call it dependent or not independent if you want. So even although I don't know what the story is about who A is or who B is, can I still make the conclusion that A and B are dependent events, right? One is affecting the other. And the reason we could do that was the fact that we know that they're mutually exclusive, and therefore this probability is not the same as that one. And the other story is you're now told that A and B are complementary events. Can you remember what complementary events are? If 2 events are complementary, what does that tell you about? Any ideas? Complementary events.
Is that when they add up to 1?
Yeah. So A and not A, right? It's raining or it's not raining, right? It's a red card or it's not a red card, right? It'd be a red and a black would be examples of that. Aren't complementary events just a special case of mutual exclusive? What makes them different is that they always add up to 1. So that adds up to 1. But what do we know? We know that P of A plus B of A is 1/2 or 1/4 plus 1/2. But that is 3/4. So the question is, are A and B complementary? If they were, shouldn't they add up to 1? But they don't. So A and B are not complementary. Okay, try one. A and B are mutually exclusive, right? So you're told that. That's 1/7 and this is 6/7. Are A and B complementary? Yes. Suppose they're mutually exclusive. And this is 1/2 and this is 3/4. Are A and B complementary now? Suppose it was 1/2 and 1/4. Suppose it was 1/2 and 1/2. So if you know or are told that they are mutually exclusive, can't you very often find out whether they are complementary or not, as long as you tell me what the probability of each individual one is? Did that help, Barbara?
Yes, so as far as if you were to ask then, if they're mutually exclusive, will they never be independent? If you're mutually exclusive, you can't be independent, or do you have to do that?
Mutually exclusive and independent events very often get confused in people's heads as that if you're one, you're also the other, right? And it's a little bit messier than that. Some mutually exclusive events are independent and other mutually exclusive events are not. I'll give you an example if I can. Suppose A was red cards and B was kings. Would you agree that they are not mutually exclusive? Okay. Now, the probability of A given B. So that becomes the probability that you choose a red card given that it was a king. Well, if you're told that it's a king, there's only 4 cards. Of those, aren't 2 of them red? And so that is a probability of 1/2. Now, what's the probability of A? Well, that's just a probability that you have a red card. And aren't there, out of the 52, aren't there 26, which guess what, is 1/2. If this guy is equal to that guy, aren't they independent events? So can you see here's a situation where the 2 events are not mutually exclusive, but they are independent of each other. So it's not, it depends on the circumstance whether mutually exclusive events are independent or not independent, right? They're 2 separate things, right? One is simply, do they share any events in common? That's what mutually exclusive does. And independence is more, does the probability of one thing happening affect the chances of the other thing happening? And that's not the same as mutually exclusive or not mutually exclusive for that matter, right? I wish I could give you a simpler answer, but do you get what I'm saying here is that they are not equivalent. If you tell me 2 events are mutually exclusive, I do not know if they're independent or not. There's not enough information. If you tell me that they're independent, I still don't know if they're mutually exclusive or not either, right? It depends on the circumstances. You can pair any one from each and it could happen, right? You could have a mutually exclusive and independent. You could have mutually exclusive and not independent, right? And so on and so forth. They're a nice, long, vague answer for you, but that's the answer. Okay, anybody got a question? I don't mind Barbara. I don't think a lot of people mind Barbara giving questions. A lot of people are just here to, you know, listen to other people's questions and say, oh, that's interesting. I forgot about that.
Question, but is there any way you can go over like a majority of the formulas and just kind of?
No, is the short answer. Not that I don't want to. There's just so many of the bloody things.
Yeah.
So what I suggest you do is just start at the first homework. There's not a lot of formulas in the early stuff, right? Or at least if there is, it's like calculating the mean, and you'll know you add them up, divided by how many. But start at the beginning, and then just every time you see a homework question that involves a formula, write that formula down with an example of where it was being used. I mean, there are, God, the thing is, there's so many. Isn't the formula for calculating confidence intervals? And it depends on single mean, difference between 2 means, single proportion, difference between two proportions? Aren't there a formula to do with the sampling distribution, right? The things we over the square root of n. Isn't there 1, 2, and 3 standard deviation rules? Aren't there means, interquartile range formula? Isn't there a formula for upper fence and lower fence? You see, I'm just ranting on all over the place, and I could keep going for the next 10 minutes, and we wouldn't be able to write them all down in that time anyway.
Okay.
So, just look at the homework and say, oh, I needed to use a formula here. I'll write that formula down. This is the kind of question I would use it in. And I would probably keep all your formula stuff in the same place, like whatever it takes, 3 pages or 4 pages, so that when you come to, oh, I need a formula, you only need to go to 4 pages. You don't need to look through 20 pages to find it. Because isn't the kind of question, I'm assuming, the kind of things you're going to have is, aren't you going to have a list of vocabulary? This is what a cluster sample is. This is what placebo means. This is what a double blind means. You know, that kind of vocabulary stuff, right? But when you also have, this is a formula and this is when you use it, right? And I would probably try and keep them separate, because I think if you know what you're looking for and you've only got 4 pages to look through, it's much quicker. The more you have in your brain, the better. Like Eric did that P1 hat, that could save you 3 minutes, but 10 questions, couldn't that save you half an hour? I mean, it adds up.
Can you go over the thing that we just did, like the P interval thing with the homework we just did like a few days ago about
Okay,
how to
so we're in,
tell.
right, so we're in hypothesis testing, because that's what we've been doing.
Yes.
Okay, so there's
And
a
like
keyword.
the how to tell whether you should be finding out if it should be above 0.05 or below. So I don't really get.
It's always below. So if you've ever had a thing above or below, it's always in terms of below, and then it's yes or no. So do you want me to do one with proportions, or do you want me to do one with sample means?
Sample means.
Okay, so do you want a single sample mean or difference between 2 sample mean?
Let's do single.
Okay, so let's suppose that a scientist thinks that, or a medical person, I don't know. Barbara, you've been put in the spot here. What's the average temperature for a normal adult male? Do you know?
98.7.
Right. So you don't know this because I'm making this up, but did you know that they believe Scottish males have a lower temperature than 98.7? Right. And it's totally made up. So it's not true, but let's pretend it was, right? So Scotsmen, for some reason, have a lower temperature. Maybe because we stay in, colder climates, our body has adapted, right? So that's what this doctor believes. So the null hypothesis is going to be that it's the same as everybody else. And the alternate is going to be that he thinks it's less than 98.7, right? Because in my story, didn't I say Scotsmen have a lower temperature, right? If he thought we'd higher temperatures, wouldn't we just make that greater than 98.7? And if he said, I'm not sure what it is, but I know it's different, wouldn't we do the not equal to in that case? Right. From what I've seen in WebAssign, if they don't specifically say bigger than or less than, will we assume it just means not equal to, right? That seems to cure a lot of the homework questions as well. So this is what I would call step 1. Now, we're going to have a significance level, and we're going to pick 5%. And he went out there and he collected 200 Scottish adult males' temperatures, and he got the answer that it was 98.5 degrees. Would you agree that that's lower, but not like miles lower, right? It's just a little nick in the temperature. And we are going to see whether or not this sample can prove this. That's what hypothesis test is about. Have you got evidence in your sample that proves this thing? Right. So you could certainly do this by hand, or you could do it by salt. Do you want me to do it by hand, or do you want me to do it? I'm going to do the end by salt no matter which way we do it.
Do it over salt.
Good. I'm glad you said that because it makes it quicker as well. So if you give me a few seconds just to get into a question like that, and we can do salt. Okay. Come on, load up. Pain in the patooey. Barbara, if you do have a colder temperature, is that any significance? Well, what happens is it you've got the opposite of a fever? You got a chill?
If you're cold,
Uh-huh.
is that what you're asking? You
Yeah.
could be septic. That's often a sign that you're sick.
So septic means you get poison in your system, I'm thinking?
Yeah, like they're in your bloodstream. Yeah.
So why does your temperature go down? Is there a reason? I'm just nosy.
I think your body is going into shock. So it's trying to
Ooh.
protect all your major organs, like your brain and your heart. And so it's everything else is shutting down.
Interesting. Okay, right, I'm ready. Is there a number, not that you need to know it, but is there a number that you would be really worried about? I mean, if somebody was 0.2, you wouldn't really be too concerned, would you?
No, but I would take into consideration how you're taking your temp, because I'm sure everybody noticed when you take it from the outside, everybody's getting like 96.4 and things like that. And that if you got a temp like that using a rectal thermometer, I'd be extremely concerned. But if I got it on the outside, it doesn't really matter.
So even 0.2 is serious if it's a real temperature.
I would be concerned because you have your normal range, and it would make me consider other things.
Gotcha. Interesting. If you were in hypothermia, would it be noticeably different?
Yes, yeah.
Are we talking degrees difference or just a
Mm-hmm. Yeah.
factor?
Yeah.
So here goes. We're just using this to hit the salt button. When you are doing hypothesis testing of any kind, hit inferential statistics. I'm assuming that you can see what I'm at right now, right? So one sample T, perfect. The sample mean here was 98.5. The standard deviation, I forgot to tell you, so I'll tell you right now. The standard deviation was 0.1. You would be given that in the question, right? And it was 200 people that this was done with. And we are looking for a 98.7. And in this case, we're trying to prove that our sample is proving that it is less than that. So if I hit generate results, can you see they already tell me the null and alternate? And the key number that we need is that p-value there. So pretty much, I mean, if the question said, what's the t-score, it would be that. Isn't that horrendously big negative t-score? Which is kind of bet your house on it. You're going to win that argument, right? It's a really significant t-score. So let's return back to, if I hit the right button. What we would do now is that we would take that p-value, which has been done, and I believe it was 0.000001. I think I got enough zeros. And then you do a test. And the test for every single hypothesis test is the p-value less than alpha? Is this guy less than the 0.05, remember, from here? And if the answer is yes, what's the typical way that this is phrased when you've got that, you know, the 4 circles and you pick one? There's a couple of ways this is phrased. Can you think of any of them?
Reject the null hypothesis.
That's a good answer, yeah. They might say there is enough evidence to, but reject the null hypothesis is the key to it.
Accept alternate hypothesis.
Yep. And aren't both of those exactly the same thing? Just they mean the same, right? Isn't it basically saying, yep, you've proved that Scotsmen, on average, do have a lower body temperature, right, than the typical population. Now, just for argument's sake, can we pretend we did the p-value and it ended up being that number? Right, could happen. So when I came to do the test, right, and I asked, is this true? Wouldn't the answer now be no? And what do you say when it's no? What's the jargon phrase?
Not enough evidence to reject the null hypothesis.
Yeah, and I think in that case, isn't that really the only sentence that you would use? They don't have an equivalent, so not enough evidence.
What made it no? Because the other one was yes.
Oh, if this number is not less than 0.05, so your p-value, if it's less than 0.5, yes, you've got evidence, you've proved what you wanted. If the p-value is bigger than that, and we're not phrasing it that way, but that's the same thing. Isn't 0.07 not less than 0.05, just another way of saying 0.7 is bigger than that, right? But we tend to always phrase it in terms of this. So is this less than that? Nope. And when it's no, there's not enough evidence to reject H naught. If the p-value was 0.1, would you say yes or no to the test? If the p-value was 0.1. Shaking your head, Eric, so that's a no, agreed? And when it's a no, don't you write that, Geiger? Suppose the p-value was 0.01. When you say yes, and when it's a yes, you'd say, hey, I've proved whatever it is we're trying to prove. In this case, you could phrase it with reject and null. You could also phrase it as accept the alternate. These two are totally equivalent. So it's all about the value of the p-value, Isabel. If the p-value is nice and small, you're going to say yes, and therefore one of these is your typical answer. If the p-value is kind of on the big side, you're going to say no, in which case you're going to read
I think I was just reading it wrong because it said 0.5 instead of 0.05, and so it looked incorrect. I think that's fine.
Okay, we're good then.
Thank you.
Where are we off to? Oh, I'm just, my brain works this way, so I got to get questions out of my head, Barbara. So you're my resident person. So you know everything about everything medical. That's like I know everything about Scotland, which I don't. But is there I have seen questions from this that says women are warmer than men. Is that true that the average woman has a higher temperature than the average male?
I don't know. I don't know
Okay.
the answer.
This one I don't know. I'm just curious. Maybe you do know. Is there some genetic differences? In other words, Inuit people might have a naturally warmer or colder, I don't know which direction, than someone from the Sahara. Do you think there could be some genetic variation in temperatures just to do with the fact that you've been living in a certain area and maybe being hotter or colder would be of benefit? And it sounds to me like it might be true. I just don't know. I've never heard of it.
I feel like that might be possible. And I know that my average temperature usually stays around 99 mid to high. That's usually where I am.
So if you come from a colder climate, you might be warmer because generating some more heat is probably a good thing if you're in a cold climate.
It seems like that's a possibility. Like
Yeah.
that isn't inconceivable.
Yeah.
And I
Is
know
it-
that I have a warmer temperature than basically everyone I know.
Interesting. Your body is at that temperature because isn't that the temperature where the chemical reactions that happen in your body like to be? Is that right? That if you get too hot, your body chemistry gets screwed up and it doesn't do its job right? I'm guessing. See all those daft questions that come into my head because they do.
No, I like questions like this. It's interesting.
Yeah. Then you have to, then you know I'm going to end up when I leave going online and seeing if there's any evidence to that. They might come back and say no because it's kind of hardwired into us that we have to be that temperature. It might be that as well. Okay, focus, Donald. Where are we off to now? Or are we off to anywhere? We kind of burnt out. Barbara, you got another one?
I do, if that's
Go for
okay
it.
with the group. And it's chapter 9, sampling distribution for probability A, I think,
Okay.
or
Chapter 9,
proportions
sampling
A.
distribution. Oh God,
Or-
I've got a lot of sampling. I've got sampling distribution for proportions B. Does it sound like that one?
No, it's for proportions A.
Okay, I got that one as well. Okay, so let's click on that. Any specific question from that
It
section?
was number 9.
Okay, click on it. It's quite a long question, so
Mhm.
let me just go to the screen. I think it'd be quicker just to talk through it. I know the answers are there and that'll be a little distraction, but it's probably better just to be there than not. So question 9, an automobile club comes to the aid of stranded motorists who are members. Now over their long run, about 7% of their members utilize this service every 12 months, right? So if you're a member of AA or AAA, whatever it's called, right, or Breakdown Services USA, whatever they're called, you pay them $100 a year. And if you break down, they'll pick you up and take you somewhere, and that's what you're paying for, right? If you don't use it, you've got the peace of mind of knowing that, you know, if you do break down, you're safe, right? That's essentially what all insurances are about. So in this case, 7%, that's what they've discovered. Now they have a small town of 400 members. So what they're really telling me here is a sample is 400. Now they might not have phrased it that way, but isn't that what you've got? 400 people. And we're going to look at these and we're going to look at them to be a representative of the larger club membership. Okay, so let P hat be the proportion of them who will utilize the service in the coming 12 months. Okay, so P hat is going to be whatever that is. Now explain how the following conditions for the approximate normality of the sample distribution. So what we've got here is an actual population with a fixed proportion, right? People who are a member of the service, isn't it meant to be 7% on average, right? It's a single value. I don't think that's a very clear question. Either a random sample is selected from the actual population. Well, a random sample is selected from the actual population. The second situation is where you repeat something lots of times. A totally different story. Suppose I had a dice and I thought, you know, I work in a casino and this guy is just getting too many sixes to be lucky, right? And I think his dice is dodgy, right? One of the ways I could test that, couldn't I take his dice and roll it 600 times and record how many sixes I got? Shouldn't I only get 100 out of 600 typically? Right, 1/6 of the time. Suppose half the time I was getting a 6, wouldn't that be a worry to you? Wouldn't that be, this dice isn't doing what dice should do? That would be an example of repeated process, where you're taking one thing, a dice, and doing it 600 times. Here, aren't we doing 400 different people? It's not like we pick one person and do something to them 400 times, right? That would be the difference. NP is 28 and N1 minus P is 372. So if you take 400, which is n, and you multiply it by p, which is 0.07, that's where that 28 comes from. And n 1 minus p is that. Why are these two numbers being calculated? What's special about np and n1 minus p?
They have to be greater than 10, don't they?
That's it. It's called a 10 rule. If one of those numbers was less than 10, shouldn't we kind of stop there and say, no, you can't do this test. You can't do confidence interval. You can't do hypothesis test. Whatever it is you were going to do, it ain't going to happen, right? It's 10 rule, right? If it was samples where we were doing means and whatever, things like that, how big should the sample size be if you want to be safe? I've mentioned the number. How big should a sample be when you're doing means?
30?
Yeah, about 30. Now, that's not carved in stone. You'll go to some textbooks and they'll be happy with 20, and you'll go to other textbooks and they'll probably say 40, right? But, you know, let's say 30 is a good number to work with. So, would you agree that this is perfectly safe? N is 400 and P is 0.07, right? We got them from the story. Isn't that 7%? And isn't that the 400 people? Now, describe the sampling distribution. Let me leave this for a second and talk about the theory then. There is a special distribution called the sampling distribution. And the sampling distribution is typically normal, right, symmetric and checked. And the guy right in the middle, won't he be P? In this case, 0.07. What is the formula for the standard deviation of a sampling distribution? Now, bear in mind that we know P, because we're going to use it.
The square root of p times 1 minus p all over n.
There you go. Now, if you do that calculation, can you just trust me, because I've got it in front of me, that you get 0.09. And so if I do my 1, 2, 3 standard deviation thing, right, that guy there, if you put this guy, won't you get 0.916, 0.25, and finally 0.34. I'm a little bit, 0.9, yes. Yeah, okay. I'm not really sure I can go this way. Would you agree I'm going to run out of numbers before I run out of probabilities? And actually, they didn't ask you to draw that picture, so I'm kind of glad. Now, it says, what is the approximate probability that the actual proportion requiring aid will exceed this value? So we are trying to find what's the probability that P hat, right, our sample, is bigger than that, okay? Now, what do we need to know to be able to do that? Well, don't we need to know what the mean is, which is 0.07? And don't we also need to know what the standard deviation is, which is 0.09? And just checking anything here. Right, so I'm going to have to hit salt again. And eventually, I'm going to go in and do one of those normal distributions if this damn thing will let me. Right. If you do use salt, and it's on the right place. Normal distribution, the mean is 0.07 and standard deviation was 0.09. And they want to know what the earth do they want to know? What is the approximate that the actual proportion requiring aid will exceed this value? What value? Oh, there you go. It's not 0.07. It's 36 out of 400, and 36 out of 400 does change my answer a little bit. Let's figure out what that is. So they want to know 0.09. Well, okay. So I need to know what is the chances that it's right-tailed and 0. There's something not right here. I'm going to put it in anyway, and then I'll figure out what the damn thing is. And oh, it was exceeded. That's what it is. Oh, no. Come back. There we go. That is not their answer. Let me see what the heck I'm doing now. The towing service in town contact club, 36 members. What is the proportion? Is that 400 members in town? Oh, okay. There is the guy. Do you know the one that I went and said 0.09? Remember that calculation I said, oh, I'll just write it down. I was looking at the wrong place. The number that I should be looking for is 0.0128. So, okay, so I got the right guy now, I can use him. That fella there is 0.0128. And we want to be, that's right. And we want this guy. One zero too many. Third time lucky. And there's that 9-4 thing that we were looking for.
Why do you do a left tail on that when it says it exceeds?
Right, what approximate probability that the actual required aid will exceed that value? Oh, because I should have done right-tailed. So the answer is that fella, 0.059. There we go, 0.59. And why exceeds means bigger than, but during all that back and forward, which I'm not very good at, kept on losing track of which direction the question was going. So there's a almost 6% chance that you would get what happened in this time, which is small, but not inconceivable. Can you imagine that could happen? Suppose this probability had been 0.00002. Wouldn't you consider that a really weird result? And then you'd be thinking, well, I don't know what I'd be thinking. I'd be thinking that it was a small town where everybody was trying to give the local garage guy some work. And so they all pretend to break down so that he would have lots of work to do in, picking them and towing them somewhere. Whatever the reason is, it would be weird. Okay, so let me show you my change numbers before I forget. In that last question here, it was 0.09 and the standard deviation was that. That should have been the numbers I was using. And greater than, perfect. And that ends up being 0.0585. So you can imagine it would be, well, I don't know, where would 0.9 be? Be somewhere 5%. I'm about finished for today. As we get